Hello, welcome to ANS Solver. This is the eighth question of the paper. So the diagram shows a graph which is y equals to sec x. I need to use the trapezium rule with two intervals, okay, to estimate the value of sec x, integration of sec x from 0 to 1.2. So now what I basically need to do is the formula for area of trapezium rule, which is basically half into the strip width, okay, into basically the twice of middles plus the ends. Okay, there's a concept you need to know. It's fully conceptual. Okay, so what you need to do first is you need to know what the strip width is. Basically in this curve, okay, from 0 to 1.2, let's say, okay, what I need is I simply need two intervals. Two intervals means two gaps. So let's say I can make a line here in the middle, and I can say this is gap 1 and this is gap 2. Now I know this thing here is 1.2. Okay, I need this to be the midpoint of 0 and 1.2. Okay, so I can simply do 1.2. Okay, this to calculate the strip width. I can simply do 1.2 minus 0, which gives me 1.2 over 2. Okay, so when I do that, I get my value basically as 0.6. That means my strip width is 0.6. Basically the value of this line is basically 0.6. The strip width basically means the difference. This difference, which I know now is 0.6 and 0.6. Okay, now I need to calculate the middles and the ends. Now I know my y is equal to sec x is basically 1 over cos x. Agreed? So now what I basically need to do is, in the radian mode, I know my critical x values are basically 0, 0.6 and 1.2. Okay, so I can write this x equals to 0, x equals to 0.6 and x equals to 1.2. So I can simply now write this as y equals to 1 over cos 0, which will give me 1. For this also in the same way I can do 1 over cos of 0.6, which will give me 1.2116. And in the same way what I can do is I can write this as cos of 1.2, 1 over cos of 1.2, which will give me 2.7597. Got it? So now what I basically need to do is, I know the y coordinates are important here. 1 is basically my end, and even 2.7597 is my end, and this is my middle. So I simply need to substitute in the formula half into 0.6, okay, into the twice of middle, which is 1.2116 plus the ends, which is basically 1, plus 2.7597. Okay, so now I can solve this full thing basically on the Cal C. Okay, simple thing to solve. So just solve on the Cal C, the full thing. Okay, so now when you solve this on the Cal C, okay, you basically get, just give me 1 second, solving it. You get your answer as 1 point, have they asked any, we need to give it to 2 decimal places. So 1.85 as the final answer of the question. Now, explain with reference to the diagram whether the trapezium rule gives an overestimate or an underestimate of the true value of the integral in part 1. So basically, if you see here, your curve has an increasing gradient. Okay, whenever it gives an increasing gradient, it's always an overestimate. So you can write this as overestimate because the curve gives an overestimate. Sorry, my bad. The curve has an increasing gradient. Sorry. Okay. So you need to know if the curve has an increasing gradient, it's an overestimate. If it would have, decreasing gradient, it's an underestimate. Now, P is the point on the part of the curve y equals to sec x with this domain at which the gradient is 2. By first differentiating 1 over cos x, find the x coordinate of P. So you need to know that y equals to 1 over cos x can be written as y equals to cos x the whole raised to minus 1. So now I need to basically differentiate this, which is a dy by dx, for which I can use something called as a chain rule. So first I'll take the outer bracket. So I take minus 1. So I can write this as minus 1 into cos x with minus 1 minus 1 multiplied by the differentiation of the inner bracket. The differentiation of cos x is minus sin x. So I can now simply write this as cos x raised to minus 2 sin x, which can basically be written as sin x over cos square x, because when it comes down it becomes positive. And now I know this gradient of P is equal to 2. So I can simply write this as equals to 2. Okay. So now I can simply write this as sin x equals to 2 cos square x. Now I need to solve this. So trigo identity is simply sin square x plus cos square x is equal to 1. So I can simply say cos square x is equal to 1 minus sin square x. So I can write this as sin x equals to 2 into 1 minus sin square x, which can be written as sin x equals to 2 minus 2 sin square x. So finally I can write this as 2 sin square x, okay, plus sin x minus 2 equals to 0. Now I can say let sin x be a. So I can write this basically as 2a square plus a minus 2 equals to 0. Now if you see, you need to solve this on the calci. So on the calci, what you can do is first click on mode. When you click on mode, click on 5 where equation is written. When you click on 5, you click on 3. When you click on 3, you get 3 coefficient boxes. Okay? In the first coefficient box, what you do is put 2, which is the coefficient of a square. In the second box, put 1, which is the coefficient of a. And in the last one, put minus 2, which is the constant. So 2, 1 and minus 2. So when you do that, you basically get your answer as a equals to 0.78077. Okay, and you get the answer basically as a equals to minus 1.28. Now I know sin a is basically sin x, which is equal to 0.78077, and sin x equals to minus 1.288. Now if you see your domain, it's basically from 0 to half pi. That means it's only in the first quadrant of ASTC, so it can't take any negative values. So this is out. Now what I need to do is I need to write this as x equals to, basically in the radian mode I need to do the sine inverse of basically 0.78077, which gives me the answer of 0.896 in the radian mode. So this is basically the final answer of the question. which I think I needed to write to 3 decimal places, which I've written. Yeah.